Greetings again. Greetings, everybody. This is lesson number 25, Trigonometry for Students and Surveyors. The last few lessons we concluded our horizontal curves. So now we're going to go back to some angular stuffs. A lot of this is like, it's almost like inside baseball survey stuff, but it does show you how trigonometry really applies to surveying and how trigonometry is used in surveying. It's practical trigonometry. So we'll get started on this one. What we're going to do here, this is called a resection. It's something that our data collectors do. This is going to be called this is going to be a 2-point resection. You can do multiple points. So I'll try to get you up to speed on what that really is. You're going to be maybe a little lost if you haven't gone through our earlier lessons when I talked about traversing around and closed looped and checking closed traverses and so on. So we're going to pretend that we have traveled clear around this job site, and we have a closing angle, and we had closing. Our closure was very, very tight, almost perfect. We're just going to hypothetically call it perfect. And you know that we'd set our instrument and we measure angles and distances, and we end up comparing that to a perfect polygon with that same number of angles. That's all back in earlier lessons. So I'm not going to repeat all that here. It's quite a bit to go into. Generally speaking, you'll set the instrument, this thing here, backside a known coordinate, turn angles up to this point here, sit your gun here. We call those a gun, it's an instrument. Sit there, backside that, turn an angle over to this control point, sit there, backside that, and then that's called a traverse. And you go around a block or a couple blocks or a job site, or it can be what's called an open-ended traverse. So anyways, we've done that. We've assumed that everything is nice and tight. Now we've gone around, we've checked, we've got all our stuff established, verified. It's already been put in the office and submitted to the office. They've checked it, verified it. We're all good to go. So now we can go out and we can stake stuff on this construction site. One of the things we're going to stake, one of the first things they stake a lot of times on construction sites is storm vaults. And you can get digging on those and get those built. They're quite complicated, take several months to build. Sometimes they're very, very large. They got to hold a detention vault. They're detention vaults for water, for storm water, and they got to hold water sometimes up for 150 houses or more. And if there's that, they can actually build several of these. But in this case, we've already staked the vault and they've dug it out and they've got it pretty close. Now they want us to come back. They're calling the surveyors to come back in and tight stake it so they can build the inner walls down in the hole. So what we want to do is we want to set our instrument right here on the edge of the wall. This is, of course, this is looking at it plan view. We want to set it here so we can look down inside this vault and shoot these hub and tacks right on the corners where they need to be. And these are all coordinated, and they would all be relative to our coordinate here. But we don't have anything here yet. We have this calculated, but we don't know they don't know where the gun is going to sit. This was our control point, so we can't stake it from here because we can't see over and down. So the traditional ways, you would sit here, backside this, or sit here and backside that, and then turn, set your foresight where you wanted it, and then turn to it. Let's just say we're going to do it from here. We'll sit the gun here, the transit here, backside this, set a foresight there, turn our angles to there, then pick that up, set it there, backside that, and of course we always have to check it into another third point. The other way to do that, this is called a resection, is you just set the instrument anywhere you want it here. And this looks like a good spot. It's roughly midway. It sees down into all the corners. You just set it there without any coordinate on it or anything. Now we're going to do what's called a resection, and we're going to do a 2-point resection. One of the things you have to do, you have to know that your control that you're resecting from is very strong. It's a pretty strong angle. It could be a perfect angle would be a 90 degrees, 60 degrees. This is a little bit less than that. Still a pretty strong angle. The fact that I'm not using a 60 or better angle doesn't so much reflect my surveying competence, but probably my drawing competence and being able to lay all this drawing out in my head before I start drawing. So anyways, so we ended up with this angle here, 49, 32, 44. That's your degrees, minutes, seconds, or decimal degrees is 49, 54, 56. And so that's what we have here. So we have, this is where now we're going to get where the trigonometry comes. So what we have is part of this traverse point, or this traverse loop around here. We've traveled around here, we've had these coordinates. We already have known coordinates on these 2 points here. So we've set up a tripod here with the prism aiming this way, and a tripod here with the prism aiming this way. And we have a tripod here with the instrument on it. So what we want to do is we're going to measure, so we have a coordinates on this one here, this is traverse point number 3. We're going to call this traverse point number 1 over here. And those are probably 4. This would be 5, 6, 7, 8, whatever, back to 1. This is traverse point 2. This is traverse point 3, traverse point 4. So what we have is over here, we just gave this an arbitrary northing and easting of 5,000 over 5,000. You've seen me use that a lot in all our other lessons, in all the other lessons. And over here is the coordinate on this one. Now this is a known coordinate. This is what you'll get on a thing. Here's your 2 traverse points. We've got it all adjusted and everything's fine. Now here's what your coordinates are. So there's your coordinates to deal with. So now, and this is your coordinate for traverse point 3. Now I've done it both ways, backwards and forwards and forwards and backwards. So one of the first things you need to know is you only have, now we're going to do it longhand. Now, of course, the data collector that you have, all you would do is put your point in here, call this whatever your new traverse point is going to be, say 200. Then you're going to say 2-point resection. You're going to select that option on the functions that you're going to select and work with. Then you're going to say your backside is traverse point 3, and it's going to measure it. And then it's going to turn, then you turn an angle to backside 2, and it's going to measure that, and it's going to measure this angle. And then you're going to hit, if it wants another point, if you want to add more points to that, you can. If not, you could just solve it, and it'll give you a coordinate right there. And by the way, if you're giving measure ups, it's also going to back in your elevations and put your elevation on there. Then of course, once you get that coordinate, you're going to want to check maybe over here. You're going to stake out to 4 or stake out to 1 over here and make sure that everything's good. And then you can go, then you're full confidence that everything's going to fit. Okay, so how do we get, so we have a given coordinate here, 50501660 51749496. So you'll have that. You don't really have this now. You do in the data collector. You could inverse that, but we're going to do this longhand. This doesn't exist yet. The 74 degrees, 182 feet. So what we want to do is to get. Now we're going to go back and do a few lessons where we learn to inverse points. So we're going to inverse this direction from traverse point 3 to traverse point 2. And so we're going to, this is our northing, this is our easting. We're going to take the northing 5,000 and subtract 5,050, 1660 from it. And we're going to get 50.1660, that's our northing. Then our easting is 5,000, we're going to subtract 51749496. And we're going to get 174.9496, and that is our that's the difference in the northing, the difference in the easting. And as you can see, I've already drawn it, but you can see we're going to the northeast, so there's really no corrections made for bearing. So now we're going to subtract. Now we're going to inverse those, and we're going to divide the easting divided by the north. These are going to both be negative numbers. Now, again, you don't want to get confused. We're going in a positive direction, but since we're subtracting this lower number from that, we're going to get negative numbers. If you go the opposite way, you're going to get, even though you're going in a negative direction, you're going to get positive numbers. It makes sense if you do it enough. All right. So we divide the easting over the northing, and we'll get 74 degrees. So there's our bearing, or azimuth. It's 74 degrees, being 0 to the north, 90 to the east, 180 to the south, 270 to the west, that's 74 degrees. Now, how do we get our distance, our hypotenuse? Well, we know how to do that. That's a squared, b squared, and the square root of those two. Or you can use the trig functions and do it the long way with 74 degrees and use your sine, cosine, stuff like that, and to get that. And that's also in the past directions, but I don't want to get too hung up on that. So that's how we get that. Now, if you have that to start with, you can enter 5,000 in your data collector. You can go 74 degrees cosine times the distance, and that'll give you 50.1660. You add that to 5,000 and you get 50.1660, and then you can take 74 degrees, the sine of that, times 182 degrees, and you'll get that number there, and then you'll want to store that. Because what we're going to do is calculate this point based on this one, then we're going to go and check it and check it on that one, and we should come up with the same coordinate right here. Okay, so we've measured that, we have that. What do we need here? We need to figure out, to get this this coordinate here, we need to be able to determine the hypotenuse, the angle. We need to get to bearing on this. We need to understand what this bearing or this azimuth is. We know it's 213 feet because we've measured it from here. By the way, if you're also doing this and for some reason you don't get the right solution to it, you can also, and I've showed this many times, the law of cosines. You've got a distance, and you've got an angle, so you can use the law of cosines. A squared plus b squared minus 2 times a times b times the cosine of the angle, and then you take the square root, and then you subtract that, and then you get the square root of that. That'll give you that distance. So if you have an extra hub here and you set up on the wrong hub and tack, yeah, it shouldn't measure right unless you somehow have two hubs exactly the same distance, which you're not going to have that. So anyway, so that's a way to check that. This is again more trigonometry, how it all sort of supports each other as you're going through this. All right, so we set the gun up there, we measure this angle, all that checks out. So now we need to get a coordinate on here. We have a coordinate here, we have a coordinate here. So now we need a coordinate here, then we need to check it. So how do we do that? So we need this azimuth. So how do we get this azimuth? Okay, so now we go over here to the law of cosines. SSS means the side case. What that means here is if you know, and there's all kinds of different sines and laws of sines and cosines depending on what you have. You might have angle, side, angle. In this case, we have an angle, but we also have side. So we could also use the angle side case and be able to solve it. But we'll keep it simple now. So these are uppercase. And let me grab my calculator here. I'm on good old HP. Now this is a reverse Polish notation, so I'm going to be talking in that kind of reverse language. So just reverse that to talk about if you're going to use a regular algebraic type of a function. So what this means is, this is how it's written in the book, basically. Only they don't even put the arc in there. I write that in there because they don't tell you that. Cosine of A. So this is angle A. Now remember, in the earlier lessons, angle A, opposite that is the side A. Side means the distance of the length of the section, and the angle is the angle, the measurement of the angle. So now we have B. This is the angle. This is the side B. C is the angle, and the side C is 213 feet. So now you just go through and figure out which one applies for the one you want to do. Well, we already have, we have the angle, so we don't need to solve that angle. So we're going to, let's solve B. I guess that's the next one down. So let's go with B. So remember earlier I talked about how in oblique triangles, you have this two sides and the opposite of the angle, they kind of go in groups all the time. So let me try to make that a little bit clearer. So up here, so we're trying to solve this angle here. Trying to solve angle B. Let me write that in here. Yeah, let's work with this one first. All right, that's B. Now, what we want on B is a squared plus c squared minus b squared divided by 2 times a times c. Then we want the arc cosine of that to get that angle. So we want a squared. I'll go ahead and work that out on here. We're not going to take this distance because that's the angle we have. We're going to take these two. So a squared is 182. We're going to hit squared. Find that on your calculators. 33,124. Now we're going to go c squared. So that is 213. And then we're going to go to the square root of that. 45,369. Then we're going to hit plus. Now on yours, you would have hit a squared plus and then b squared equals. So that's not how I do that, though. That's not how you do with reverse Polish notation. Now we're going to go. Now we're going to go b squared. That's the opposite now of the angle. So 221 squared, and on this one you'd go minus. And on yours you would go minus 221 and then hit squared. So I've got 29,652. So that's this one up here. So now we're going to go down 2, enter, and you would go 2 times. What do we want? And then A and C again. We want these two. So 182 times 213 times. I got 77,532. And now we want to hit divide. That's 0.3842. Now we want the arc. We want the cosine. We want the arc cosine. That's the angle of that ratio. And arc cosine is 6751.46. This is in decimal form. All right, that's in decimal form. Let me double check that. Yeah, we're good. So I have that stored as B. I already have that worked out and stored as B. Let me recall that just to be sure. So recall B. Oops. Recall B is 6751.46. Now B on this one here, when you hit store or recall, it activates the alpha. And then I have A, B, C. So I just correspond the angles A, B, C with those. Then I skip a line, and then the corresponding sides for that angle, the opposite side is over here on H, and the opposite side of B is down here on I. The opposite side from the angle C is directly below it on J. The reason it's not on this row is because recall doesn't have an alpha option to it, so you have to kind of skip over that one. So I just go to the next row down. Learning to store and recall your numbers is really handy, and also because even though it's showing 4 digits, and I've showed you this before, you can go show, and it'll show you all way out there, like 8-10 different 8-10 decimals to the right, and even more. So there you go. So there's that angle right there. Okay, that's great stuff. We have 74 degrees that way and even 74 degrees. Now if we add this angle to it, that'll give us this bearing here, this azimuth here. So let's just go 74 plus 141, 51, 46, and that's our bearing, or that's our azimuth. And again, I've written that in decimal. These are convert real easy. You just hit Shift key. On this one, it's 8 HMS, and it's 141.30.52. Okay, so that's that. That's the azimuth, 141.51.46. You can read that. All right, so now what do we do? Well, that's really all we need to get this coordinate right here. So we want to go, we have 5,000, 5,000 to make it real easy. We want to go, you know what, I'm going to write that in better. I'm going to just write that in a little bit better. Recall 4. Can't really see it that well. Let me go back to green on that. One 41, 51, 46. That's going that way. All right. And that makes sense if you have a protractor. This is why I have these grid lines here. These are straight, north, south, east, west. If you were to put this here and put your compass right on there, or your protractor right on there, you're going to get your right. So there's 140 there. So yeah, there it is. That pretty much matches. That's why I, you know, when I first started this, have graph paper, a scale, a protractor, mechanical pencil, maybe even a compass. It really helps you. Can you draw it all out and get pretty darn close. Okay, so we have that. So now we earlier before when we learned to traverse, what we do is we carry our coordinates called latitude and departure. So that's what we're going to do here, and we're going to start out with 5,000, 5,000. So we're going to go 150, 141, 51, 46, which I have as 4, so that makes it easy. Recall 4. Now the cosine represents the northing, sine represents the easting. So we're going to go cosine, and that's a negative 0.7828. Now we're going to multiply it times the distance, 213 times. So it's a negative 166.7292. We're going to add that to the northing. Northing, make sure we write that in there. And easting. So now we'll add that negative number to the northing, and we'll go 5,000 plus, and we have 4832708. Don't know if I have that written down. Yes, I do. Okay, so sit down for a minute. Time to go northing 4833 2708. Easting. Same thing. Now we're going to go, I'm going to recall that angle, recall that azimuth. 141, 51, 46. Now I'm going to go sine. That's going to represent the easting. And it's 0.6223. Now the reason this one was a negative is because we're going south. Everything north and east is positive. Everything south would be negative on the northing. And anything going west would be negative on the easting. So we're going to do that, and we're going to multiply that now. 0.6223. We're going to multiply that times 213 times. Now we're going to add that to the easting. This is our coordinate where we started out at. 5 times is 6. No, let me start over. Did something wrong talking. Let me hold my book here. Of course I did. All right. So we're going to go recall 4 is the bearing, is the azimuth, and then we're going to go sine, and now we're going to go 213 times, and then we're going to add it to 5,000, and that's 513.5532. Something went haywire as I was talking, so that's how you do it. 5132.553. 2. All right, just in case I confused everybody, we're going to do that one again because I blotched it up. So that's our azimuth, 141.5146. Now we want the sign of that. That's already in digital, or decimal, so you don't need to change it. You don't need to convert it back at this point. And then we want the sign of that, 0.6223. Multiply it times 213 and 132.5532. Basically what that is, that's this triangle, part of the triangle that way. That would be this, the cosine of this, or the sine of that, or the tangent of that one. Anyway, so that's what it is, 132.5, add it to 5,000, that's your new coordinate. So now you know where you're at, and we've also, you know, we didn't write any of that down, but we would have the zenith angle in here. We would have all our measure up, so we'd also be having our elevation would also come in, and we have northing, easting, and elevation would come in all at the same time. So let's check that one out, and by doing it from the other side, this data collector does this automatically, of course. We need to know this bearing, this azimuth here. So how do we do that? We got to figure out this angle. So let's go figure out this angle. We need to figure out this angle right here. Well, we know that it'd be pretty easy to figure it out. If we added that angle and minus 180, we would have that angle. But we'll do it the other way around. Let's see, what do we have here? We're going to have to use the law of cosine, side. We're going to figure out C. So here's C. So we need a squared, b squared. So this is a squared, this is b squared, because you see, and then this will be the opposite one. So let's start all over. Good practice. A squared is 182 squared. That's 33,124. B squared, 221 squared, 48,841. Now we're going to plus that. And now we're going to go minus c squared. Well, there's c squareds there. So 213 squared, and then minus 36,596. And then we want 2 times a and b times a times b, and then divide that. So we're going to go 2, enter, 182 times, you would do it different, and then 221 times. That's 80,444. Divide 0.4549, and now we want the arc cosine, because it's the law of cosines. Now the only way you're going to remember these is to write these formulas down, and if you can remember them, then you're doing better than I am. I usually write them down and refer to them back when I'm getting ready to use them. So law of cosines, now I want the arc cosine is 6293.99. That's looking good. Let's write it in this color. 6293.99. I believe I have that stored as C. We'll go recall C. I do. Now if you want to just convert that just to C, that would be written as 62:56 minutes and 24 seconds. 62 degrees, 56 minutes, 24 seconds. So now we have that. Now, so we have this angle. So how do we figure out that? Well, what are we going from? We got a bearing this way. So let's just go ahead and do a back bearing on that. So 74. Now this is all in earlier lessons. Enter. 180 degrees plus. That's 254 degrees going that way. And that's your back bearing, back azimuth. All right, now you have this angle from it, so we could just subtract that angle from it. You could also go 180 degrees, and there's different ways to get to this angle, but I just think right now the easiest way is just to subtract this angle this angle right here from it. So we'll go in 254, enter. We're going to go 62, 93, 99. Is that what I had? 62. Minus 191.0601. And that is that. 191.0601. That's your back azimuth. Let me see. I should have that stored. 191.0601. So that's the back. That's the new foresight from there. Okay, so that's your foresight. Now we can do latitude and departure. Now that we have that, and again, if you put the protractor up there and looked, what did I do with it? What did I do with it? You can see, let me go to this one and get those lined up. You can see there's 196, or no, 191. All right, so that's all kind of checks out. Now we have this coordinate on this one because we created that by latitude and departure, or we actually were given that one to start with. So what we need to do right now is enter that into our data collector or into our calculator. A lot of times I just completely, as I'm traveling through, you'll see where when I travel through on the traverse, on the control loop traverse, I would solve one and then move forward to that one, and that it would all continually overwrite these. But we're not going to do that. We're doing a little bit different here. So I already have these stored as 8 and 9. Just let me check to make sure I still have them in there. 50501660, that one's good. And then recall 9, 517494960. So that's good. Now, because we're going to add to this one now to get this one. So now we want 191.0601. So recall 7. Now I want the cosine. That's going to deal with the northing. That's a negative 0.9814. Of course, it's a negative because we're going south. And now we want 221 times. That's our hypotenuse distance. And now we're figuring out what the right angle tangent distance would be. And so we have a negative 216.8952. Let's add that to 8. Recall 8 and plus. We have 48332708. Okay, so we'll write it in brown this time. 48332708. And then easting. Okay, we're going to go recall number 7. 191.0601. That's the azimuth. And now we want the sine of that, which that deals with the easting. That's also a negative, which makes sense because it's 180 be down there. It's going back to the west, so that's going in a negative direction. And now we want 2, but it's a small number, 0.1918. We want to go 221 times because we're multiplying it times the hypotenuse. And we're getting 4239.64. We're going to add that to the easting there. So it's a negative, negative 4239.64. So let's add that to the easting up there. So recall 9. And we'll go plus. And we're 5132.5532. 5132.5532. So that's where we have it. We have that coordinate there. They're the same coordinate. Now, if we were to resection off of this one too, as long as it was a perfect polygon, it would create this triangle, and we'd end up with the same coordinate again. So that's where we're at. Now we set there. Now we have that. We already have the gun there. So now what we have, that new coordinate, we want to pick one of these to backsite, re-zero our gun, check to a third point. Now that we have a new coordinate, we want to check to one of these third points again. And then make sure we hit those good, stake out to those, we hit those good, horizontally and vertically, elevation. Now we're ready to go. We enter in these points here that have their own coordinates on it. And it's going to tell us what angle to turn, what distance it is, and then we're going to go out there with our rod and our prism, and we're going to stake those right where they're supposed to be, right exactly where they're supposed to be, within a millimeter or two. And that's called tight staking. And that, so make sure you have this law of cosines, and this is one you should always know, is the law of cosines. When you have the angle and the two distances, you can always calculate the distance across here. This law of cosines is showing you if you have side, side, and side distance, you can calculate. And then if you go back to our earlier oblique triangles, we did just about every iteration of this that you can do. So you would have two sides and an angle is another way to do it. You could have two angles on one side. The only one you can't do is three angles, angle, 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 because a triangle can be bigger or smaller and have the same angles, not necessarily a distance. So you're going to have a distance in there. But I think that does it. That solved that. That's called a 2-point resection. I know that's a little bit specific to surveying, but it does show for students, it does show how we do use trigonometry in our work on this stuff. So I hope that helps you keep a little more interest in it. And now we're going to do some other stuff. We're going to do some little trickier stuff, some boundary stuff, travang in and calculating points on a property line. So that'll be kind of fun. I think we're going to do that probably the next time. So this was lesson 25, and thank you very much. That's it. Take it easy. Oh, like and subscribe, please.